Art on the one hand, science on the other, the first driven by human feelings and preoccupations, the second seeking to uncover truths about what is out there, irrespective of our sentiments. Inner worlds versus outer worlds, the subjective versus the objective. For many, such cliches seem pretty close to the truth. Perhaps this helps explain why Leonardo da Vinci is such a modern hero to us. We're astonished by his genius. How can it be possible that the same man who painted the Mona Lisa and the Last Supper was also a mathematician, an engineer, an anatomist who discovered how the aortal valve works 450 years before our own doctors did, not to mention sketching plans for helicopters and scuba diving gear. But here are two facts about Leonardo. First, he had the habit of going to the markets, buying birds in cages, and then setting them free. And second, he perfected a painting technique called sfumato, the essence of which was to blur the boundaries between any two objects. Leonardo himself, it seems, would have shouted from the distance of 500 years at us hyper-professionalized moderns, why have you incarcerated yourselves in such man-made boundaries? Why the gross separation between science and art? Vladimir Nabokov, an artist and scientist closer to our times, recognized the truth in this. Scientists are no more unimaginative observers, he knew, than artists are undisciplined dreamers, unfettered by earthly realities. Nabokov had discovered in the science of butterflies the non-utilitarian delights that he'd sought in art, and both to him were a form of magic. The tactile delights of precise delineation, he wrote, the silent paradise of the camera lucida, and the precision of poetry and taxonomic description represent the artistic side of the thrill which accumulation of new knowledge, absolutely useless to the layman, gives its first begetter. There is no science without fancy, and no art without facts. Tonight, I have the pleasure of talking to another special human being who appreciates that the interplay of imagination and observation, as much as the convergence of truth and beauty, are the mark of all creative human endeavor. Alan Lightman is a physicist who has made contributions to the theory of astrophysical processes under extreme temperatures and densities, focusing specifically on relativistic gravitation theory, the structure and behavior of accretion disks, stellar dynamics, radiative processes, and relativistic plasmas. He also happens to be one of America's finest writers, the author of such classics as Einstein's Dreams, The Diagnosis, A Sense of the Mysterious, and Song of Two Worlds, among many others, about 30, in fact. And one of the first people at MIT to hold joint faculty appointments in both the humanities and the sciences. Alan was the force in the 1990s behind the establishment of MIT's communication requirement, which requires all undergraduates to receive training in writing and speaking in all their 4 years. And he was the co-founder in 2005 of the graduate program in science writing. Around that time, he also founded a wonderful nonprofit organization called Harpswell, whose mission is to help advance a new generation of women leaders in Southeast Asia. Fittingly, he is professor of the practice of the humanities at MIT, and most importantly, a generous and lovely human being. In tonight's discussion, I'm going to ask Alan to share with us his thoughts about how science and art are similar, but also on how they differ. In particular, I'm curious to learn from him whether and why, when artists approach science, or for that matter, when scientists approach art, there are divides between fact and fiction that need to be respected. Another question I'd like to pose is, are science and art converging in our day and age, or are they further disbanding? And what does the future hold? will crossing boundaries between different forms of inquiry into our world and different forms of knowing become more crucial for our children than it is for us? And if so, how should we help prepare them? Welcome, Alan, and thank you so much for being with us. It's really a true pleasure to have you.
Well, it's nice to be with you, Oren, and I think that you're also a fabulous writer, and you bridge the arts and the sciences yourself.
Well, that's very kind of you. Thank you. Alan, I usually like to start with a little bit of biography. So my first question to you is, I understand that as a schoolboy, you won prizes in both the humanities and the sciences, but when you went to college, you chose to concentrate on physics. Why were you drawn there in particular?
I was drawn to physics because it's the most fundamental of the sciences. When I was in college, in addition to taking courses in science, I took courses in philosophy and literature, and wanted to have a pretty broad education. But my first year in college, actually, I was in the School of Engineering. And engineers, I have great admiration for engineers. They're very good with their hands, and they know how to make things work. But after a while studying engineering, I felt that I was just memorizing cookbook formulas, and I wanted to know what's behind the formula. Mm-hmm. Where did the law of the conservation of energy originate, and so on. So that led me to physics.
Well, and you're lucky in a sense that you train in the United States, where there's a liberal arts tradition. Not all countries have that tradition. But I wonder, I guess, about the time you went to college, that was maybe a decade after C.P. Snow had given his famous lecture, which became known as The Two Cultures, in a book which came out in 1959. Do you remember reading that book and thinking about it?
I didn't know about C.P. Snow until probably around 1980 or so. And, but once I started reading him, I realized that he was a kindred spirit. Of course, he didn't have a career as a research physicist. I mean, soon after he got his doctorate in physics, he became a novelist, and then he became a politician in the British government.
Right.
But he was a role model for me.
So did you have some kind of internal notion of two cultures, or did it always feel like it was actually quite natural for you to go from a physics lab to a course on poetry?
Well, when I was in high school, I had two sets of friends. And one were the kinds who, the kids who loved to do their math homework, and the other kids hated their math homework, and they liked to write poetry. And I didn't understand why, but I was able to easily go back and forth between these two groups of friends and didn't think of a sharp division between them. But it was later on, I guess, when I got into my 20s, that I realized that there really are two distinct ways of thinking about the world. The intuitive, spontaneous way of the artist, and the more deliberate, rational way of the scientist.
Right. Well, we might argue about that a little bit. I think that there's this notion of a Dionysian writer versus an Apollonian writer, and the Dionysian is sort of the picture that you painted for the artist. But there are plenty of very Apollonian, quite strict, rigid, almost algorithmic writers who are fabulous. Like Thomas Mann is one of them. But we'll return to that.
Yeah.
gradually, alongside your work in physics, you at the university, you begin to start writing poetry and prose. And I think off the bat, we'll just start with give our listeners, our viewers, a little bit of a taste for it. The prose that you wrote includes Einstein's Dreams, which came out in 1993. And I have to say, it might be my all-time favorite book of all times. I just think it's a beautiful, beautiful work of art. Would you be willing to read us a little section from that book?
Happy to.
Thank you.
There is a place where time stands still. Raindrops hang motionless in air. Pendulums of clocks float mid-swing. Dogs raise their muzzles in silent howls. Pedestrians are frozen on the dusty streets, their legs cocked as if held by strings. The aromas of dates, mangoes, coriander, cumin are suspended in space. As a traveler approaches this place from any direction, he moves more and more slowly. His heartbeats grow further apart. His breathing slackens. His temperature drops. His thoughts diminish until he reaches dead center and stops. For this is the center of time. From this place, time travels outward in concentric circles, at rest at the center, slowly picking up speed at greater diameters. Who would make pilgrimage to the center of time? Parents with children and lovers.
That's wonderful. I have to say, the way you imagined yourself into the dreams of the young patent clerk, sort of night walking the streets of Bern during the crucial months of his annus mirabilis, really brings to life what the world would be like if time flowed backwards, or was circular, or was fitful, or was discontinuous. And this was really inspiring to me. And when I read that book, I remember saying to myself, I wanted to write about science like that. But I was surprised when, in a previous dialogue between us, you said that you don't view this book as a book about science at all, that you actually consciously resisted the urge to make each of the dream worlds logically consistent with science, because you felt that kind of texture would weigh down the book. So rather than being a book about science, Einstein's Dreams suggests the way in which the scientific imagination works. And here's my question, but to make a film or write a novel or a play that incorporates science or the scientific mentality, you obviously have to avoid being didactic. They really need to succeed first as an artistic piece and only secondarily as a vehicle for information. But for you, at least in Einstein's Dreams, this meant avoiding being loyal to scientific fact altogether, except for one of the imaginations. And my question to you is there really a necessary trade-off between instructing and entertaining, between teaching and touching, as it were? Is there no way to write about facts artistically, or to use facts to make art?
No, of course you can use facts to make art. And I think that was a rhetorical question that you knew the answer to.
Yes, I want you to expand on it. Yeah.
I think that as long as the viewer, reader, audience does not feel like they're getting a lecture, then you can certainly have facts about the world or about science in a literary work. There's a wonderful novel by the Sri Lankan writer, Michael Ondaatje, the English Patient, which was made into a film. And there's a scene there where one of the leading characters, Kip, who's a bomb disposal expert, is trying to defuse a bomb during World War II. And there's a fairly technical discussion of bombs and where you find the fuses of bombs. I'm sure the IDF knows all of this stuff. And you don't feel like you're getting a lecture because of the beautiful way that he describes it. And there's a lot of drama in the scene. You're worried that the bomb's going to go off any moment and kill Kip. And there are floodlights illuminating him so they can see how to work because it's at night. And because of the scene setting and the language and the narrative, you're willing to read through this technical discussion of the innards of bombs. So I totally agree that there's a way to write, to include facts in your writing and still make it artistic. It all depends on how you do it.
Well, why is it so hard to do? Because it really is very hard to do. I'm writing a children's book right now about the disappearance of Darwin's notebooks. And my editor constantly, comes back to me saying, I'm just belabored by your explanations. Please do me a favor. And I do my best. It's just very difficult. Why are there two parts of the brain when you're preparing yourself to learn something versus to experience something?
Well, of course, there are two parts to the brain. There are many parts, but we know there's at least the right and left hemispheres. I think it's possible to learn and experience at the same time. But when you're experiencing, you need to surrender yourself to this creative world that the writer or the filmmaker or the playwright is trying to create. The participant, the reader, the viewer of the film, the listener of the musical composition, they have to be willing to enter this creative world that the artist is making. And that involves a certain amount of surrender, in my opinion. And yes, you can learn things, but whatever you're learning cannot interfere with the trip that you're on, the voyage. And so I think the art, or the difficulty for the creator, is to maintain the consistency of that world.
Yeah. I had a guest on my program some time ago, who's a brain scientist who claims that there's sort of he calls it exploitative versus explorative mind states. And exploitative means that you're drawing from memory, and explorative means that it's completely bottom up. I mean, he makes some pretty far-reaching claims. He says he claims that there's evidence for a system in the brain which is sort of binary, and you can control which mind state you're in, and also that people who are depressed do well when they shift to the explorative. But anyways. I think it's a really interesting question to what degree experience, the relationship between experience and learning in real time.
Well, I can give an example of this from my own writing. When I first started writing fiction, I started every paragraph with a topic sentence. Now, we learn in grade school that it's good form in expository writing to start each paragraph with a topic sentence, which is a sentence that names the idea of the paragraph and sort of guides the reader through the argument of the paragraph. But in fiction writing, topic sentence is fatal because it prevents the reader from entering this imagined world of the writer to be part of the scene, to smell, to taste, to touch. And if you tell the reader right at the beginning of a paragraph how they're supposed to think about all of this, which is what a topic sentence does, you totally cancel the trip.
Yeah. There's a book, I don't know if you've noticed, came out about a year ago, an English professor from Tennessee. It's called How to Think Like Shakespeare. And he makes the argument at the outset that the way we're training our kids in high school with the 6-paragraph, essay for the SAT is just killing writing. It's killing writing, and I couldn't agree more.
Yeah.
Okay, so let's go to history a little bit. We tend to think of fact and fiction and of art and science as separate categories. It wasn't always that way. I mentioned Da Vinci at the outset, but more broadly, there's this fascinating period in the history of science and culture where by the 17th century, it becomes pretty clear that Aristotelian natural philosophy is doomed. And in that period, Wunderkammern become very popular in Europe, these cabinets of wonder that exhibit everything from two-headed turtles to cherry stones that are carved with 1,000 faces to real fossils to fake fossils. So art and nature aren't separated. There's no distinction made between them, like there is, for example, when art museums and natural history museums become distinguished in the 18th century. Now, from our modern perspective, this sounds crazy. How can that be? But the question people were struggling with at the time was, what would replace Aristotelian natural philosophy? And there were all kinds of competing theories. So
experiment.
But Bacon, for instance, wants to know, whether the new theories can encompass everything, including anomalies, and not just regularities. And due to that, monsters and wonders of all kinds suddenly become much more prominent in the late 16th century and early 17th century. So when you open the annals of the first scientific societies, like the Royal Society of London and the Paris Academy of Royal Sciences, the first 30 years read like a Ripley's Believe It or Not, and when Galileo discovers the moons of Jupiter, he calls them marvels. You have people like Leibniz, serious philosophers, sending reports of a dog who could bark out 6 words in French, including chocolat, to the journals. And then by the 1730s and 1740s, scientists really become weary with these anomalies, and they start feeling like it's time for science to return to the main business of explaining regularities. But for a period, anomalies take center stage when it comes to scientific explanations, and they really destroy the boundary that had previously pertained between facts and fiction. So my question to you is, what does it mean to you that the relationship between art and science, and even between fact and fiction, seems to be so historically contingent?
Well, I think that the embrace of anomalies was somewhat of a rebellion and a rejection of the totally mechanistic view of the world of Newton and other people, that the view of the world as a giant clock where one gear pushes another and pushes another was very upsetting to people. And the whole Romantic period and art and literature and music was partly a rebellion against that clock-like view of the universe. So I think that's part of one of the forces that propelled this interest in anomalies. I think there's also just something in human nature that we like things that are off the beaten track. We like miracles. A large fraction of the public all over the world believes in miracles even today, which is anomalies. But I think that eventually the sort of evidence-based, fact-based, experiment-based methodology of science had to return and take over, because you just can't make any progress in the world in developing new medicines and developing new agriculture and all kinds of things without subscribing to the experimental fact-based view of the world. And of course, that doesn't negate the world of the artist, of the world of the humanist, but it's the scientific world is a world that has its own methodology, its own its own concept of truth and proof, its own way of gathering evidence, and it has been very successful. It's probably one of the most successful enterprises of Homo sapiens. I mean, that's why we have airplanes and smartphones and antibiotics, and why we've extended our lifespan from age 30 to age 85. So it's been a very, very successful way of understanding the world.
But would you agree that science still needs its fictions? That fictions are crucial, actually, to the scientific way of gaining knowledge. I recently read this book by a colleague of mine by the name of Jimena Canales called Bedeviled, which shows that in many different fields, from physics to computer science to genetics, neuroscience, economics, there's an underworld of imaginary creatures that continues to sustain modern science. So we've all heard of Laplace's demon and Maxwell's demon, but there's also a Darwinian demon and Monod's demon and Loschmidt's demon, and people, prominent physicists like Henry Compton and Stephen Hawking, they use thought experiments involving supernatural beings, and we've learned a lot.
Stephen Hawking doesn't invoke imaginary beings for his work. So, well, if I can start answering the question.
Yeah.
So I certainly agree that the domain of science is limited. I'm going to get to the exact question you asked, but I'm going to give a prelude to it. Science, the validity of science has a limited domain. The physical world that science deals with, in my view, is not all that there is. So that's the first point to make. And there are plenty of very interesting, provocative questions and issues that lie outside of science, like, does God exist? Or would we be happier if we lived to be 100 years old? Or is it ethical to kill someone in warfare? The whole of ethics and religion and theology and philosophy, a lot of that lies outside of the domain of science, and yet very interesting and important. The direct, explicit question that you ask is fiction useful in the scientific enterprise, if I understood what you were saying?
Yeah.
And the way that I would answer that question is that there's no doubt that imagination is important in the scientific enterprise. Richard Feynman, the great physicist, wrote a little book called The Character of Physical Law, in which he talked about how laws are arrived at in science, laws of nature. And he said that there are 5 or 6 different ways that we can describe how a ball falls to the floor. There are 5 different formalisms that you can use the conservation of energy to describe it. You can use forces along the way, all kinds of different ways. And he said they all give the same answer. How many seconds does it take a ball to fall to the floor when it's dropped from 3 meters? They all give the same answer, but they all have different pictures associated with them, different visualizations, and all of them are important when we're trying to define new laws of nature. We need to be able to think about the world in a lot of different ways. Even if they're all equivalent mathematically, they have different visual images and thus stimulate our creative minds in different ways. So I think that's the way that I would answer your question.
Right. So I think this is something that we spoke about in our previous dialogue. To me, the divides are not as clear cut. In other words, to me, science is a form of storytelling. It's a form of competitive storytelling based on a very well-defined and consensual method of inquiry and description. And the method is so well honed that it has allowed us to tell some of the greatest stories that humans have ever told. You know, the kinds of stories that have put a man on the moon and that help us beat Corona and so forth, but stories nonetheless. And they're stories because science never describes the world directly, but only through models, which among other things rely on analogical thinking and on the use of language, including invariably on metaphor.
Right, that's true, but you cannot invent a story in science the way that you can as a fiction writer. And that's because your story has to accord with the facts of the physical world. You can't tell a story about gravity in which apples fall up when they're dropped from trees instead of down. So Richard Feynman, again, if I can quote him again, he was actually on my PhD thesis committee at Caltech. The way that he described this is that science is imagination, but with a terrible straitjacket on it. And that straitjacket, which is the requirement that your story conform with physical reality, whatever that is, with experiments you do, that distinguishes it from other kinds of storytelling.
Yeah, I mean, okay, so this is where I'm going to push back a little, because I think, and intuitively, I agree with you 100%. I agree, but to push back a little bit philosophically, there's also a position that says, we need to recognize that facts, things that we call facts and entities, things like quarks and black holes and bacteria and genes and so forth, they don't actually exist out there in the world waiting to be discovered by, the lucky or assiduous scientists. Rather, and this comes from the world of sort of, science studies, and I want to hear what you have to say about it. But the argument is they are products of scientific inquiry, and therefore they're networks. They stand or fall based not on any internal sort of veracity or validity, but rather on the strength of the institutions and the practices and the tools, and indeed the rhetoric, which produces them and makes them intelligible to a scientific community and then to the rest of the world.
Well, I agree with 99% of what you said, but not 100%. And the 1%, if I agree with 100%, this conversation would not be interesting, would it? So the 1% of disagreement is that these objects that we imagine, black holes, quarks, DNA, they allow us, the imagination and the formalism and the equations that go along with them, the experimental data, allow us to make predictions about the future. And you can think of all of science as a prediction machine. Scientists can't say what reality is. That's a philosophical question. What science knows is what it gets from measurement. Where does the needle fall on the voltmeter? Does it fall on the 3 or the 3.5 or the 4? All of the rest is philosophy, but the ability to make predictions about where the meter will fall on the voltmeter is extremely powerful. And that has allowed, the landing people on the moon. It's allowed the creation of antibiotics. It's allowed the creation of smartphones. So it's a highly consistent endeavor and set of principles and methodology. It's very consistent. And its success is its ability to predict the future. So even though it's true that we don't know exactly what a black hole is, we don't know exactly what a quark is, we can make predictions using the stories, if you want to call them stories, the models, the equations. We can use those things to make predictions about where the needle will fall on the voltmeter.
Right.
And that's, an enormous success.
Yes, no doubt. But I remember reading an interview with Tom Kuhn, who said that, the coin dropped when he understood that the smartest people on the planet were sure that there had to be epicycles, and they used them to make predictions about the movements of heavenly bodies. The example that I like is Aristotle, who said that women have fewer teeth in their mouth than men. And, you want to shout at them, say, from 2,500 years. Why didn't you just, kindly ask your wife to open her mouth and just, you can't. But I think it's too simple-minded to just view these past notions as bad science. That's too simple-minded.
Oh, no, I totally agree. The way that I look at science is that it's an enterprise in which we get better and better approximations to the world, to the physical world. There's some scientists who think there's an ultimate theory, an ultimate equation that needs no further approximation. Steven Weinberg, the Nobel Prize winner, wrote this book called The Final Theory. Some physicists believe there's a final theory, some don't. But I don't think anyone disagrees with the fact that our approximations to nature have gotten better and better. And the epicycles were, a reasonable approximation to nature at that time. But then Newton's law of gravity and Copernicus and so on made more accurate approximations to nature. And in fact, we know that Newton's law of gravity was replaced by Einstein's law, which is an even better approximation. And Einstein's theory of gravity will be replaced by some quantum theory of gravity. So this is the way that science works. It makes better and better approximations to the physical world.
But we also know that, historians who have looked at these things very carefully in each instance know that, with the example of the epicycle, that the form in which our explanation, our model took shape was in harmony, so to speak, with Christian notions of the harmonious heavens and so forth. And so there's this contingent nature that, is inescapable. And to return to the Aristotelian example, Aristotle was a great empiricist. Now we're discovering, he made a lot of mistakes, but he was also a great biologist. And so he didn't get the number of teeth in a woman's mouth wrong because he didn't know how to count. And he did predict that every woman that he would meet would have, a lesser number. So if you take this seriously, then it's really a very strong argument for the power of culture.
I totally agree with what you've said, totally agree. But the proof of the pudding and what makes science a vertical enterprise rather than a horizontal enterprise is that each century, we can predict where the needle will fall on the voltmeter more accurately. And that's the measure of success. Whether or not culture influences science, whether or not individual personalities influence science, all of that is true. But nevertheless, each century, we make a better and better prediction of where the needle will be on the voltmeter.
Okay, so now we're getting down to the real. Okay, so you make a big deal in your writings about, or you have in one of your books, about the great divide between questions with answers representing science and questions without answers representing really the capacity that allows us to respond to art. So again, to some degree, it's challenged. That hard and fast divide is challenged by the history of science and the contingent nature of our knowledge. And it leads to the question that, some philosophers or, science studies scholars ask is this divide as deep as we think it is? And clearly, for a flower intelligence or a bee intelligence, a bacterium or the sun or rain or, the concept of truth or, I don't know, pleasure, are something unimaginably apart from, what we humans take them to be. So questions with answers only mean something if it means questions with answers for us. But I feel like you feel that it means more than that.
Well, with answers for us. And again, I keep coming back to the voltmeter and the needle and voltmeter. And, when I say that science deals with questions with answers, I mean that you can ask, where will the needle on the voltmeter go when I hook up the voltmeter to a battery of 3 volts and a resistor of 2 ohms and so on? That's exactly what I mean. And I really don't mean anything more than that.
Right. Yeah. I hear you. Fair enough. Okay, so there's a famous quote. Claude Bernard is often quoted as saying that I think that the origin might be with Shakespeare, actually. Art is I, science is we. There is some truth in this, isn't it?
There is. Absolutely. And I've always thought that's part of the distinction between science and art, that in art, I mean, first of all, I agree with you that any artist is not operating in a vacuum, that they're influenced by the culture around them, but they're expressing something very personal in themselves. And the scientist can express something personal in herself, but if her results are not confirmed and reproduced by other scientists, they're tossed in the garbage can. So even though scientists do infuse their work with a lot of their philosophical and personal prejudices, their work is subject to the criticism of other scientists in a way that I think makes science a collective activity. So I agree with that comment by Bernard. He was a physiologist, wasn't he?
Yeah. Okay, so let's move to education, which I know is dear to your heart. So we've established. I think we agree that art and science differ in important aspects, but they're also in other aspects not as far apart from one another as some of the cliches may suggest. What about their futures? Do you think that art and science are moving apart from each other in any meaningful way?
Well, I think there's been a lot of emphasis and concentration in the last 50 years on STEM subjects. And I think that's unfortunate. I mean, it's easy to understand why. STEM has money in it. It has military application. It leads to power in a very visible, concrete way. But I think that you can't have science and technology without human values. And I think we get those from the humanities and the arts. And I think it's extremely important that children receive instruction, appreciation, hands-on activities in the arts as well as the sciences. They're both part of being human. They're both necessary for our survival.
Why? If someone pushes you to the door and says, why? As someone who's very practical minded, science helps us solve problems. We have a host of problems that we need to solve.
Yeah.
Why are the humanities so important?
Well, science doesn't answer the ethical and moral questions. For example, I don't think that science can answer a question like, is it okay to kill an enemy soldier in time of war? Or is it okay to kill an intruder who breaks into your home at midnight. And I'm just using those as extreme examples. I don't think that science can answer those questions, but they're obviously extremely important questions. And they don't have simple answers to them. So I think that it's for the understanding of those kinds of questions and their complexity that is one of the reasons why science alone is not enough.
I think at the heyday of the humanities in the United States in the college system was in the 60s, and about 20% of concentrations were in the humanities then. Mm-hmm. That was the heyday. Mm-hmm. So students actually do tend to be more practical. Mm-hmm. Today it's down to 6%.
Mm-hmm. Yeah, that's very unfortunate. I'm not sure that politics, which of course we're seeing a lot of right at this moment, I don't know whether that can be analyzed scientifically. The psychology of individual human beings who have much power is very, very important for humanity, as we can see in what's going on right now in the world. And that's not, you can say, well, in a way it's practical because it has practical consequences in the most extreme cases, but it also requires understanding people, as understanding the human urges and the human psychology.
Right. Well, I mean, I feel that we're in a danger of culturally of being in a place where we value what can be measured, and that's to some degree a measure of a measure itself of the great success of the scientific method, because it's really won a lot of fans, but on the other hand, there's so many important things that cannot be measured.
Right. Absolutely. I totally agree with you.
And yet there's something, 400, 500 years of modern science have inculcated this notion. And I think large populations of people on the planet, that, if you can put a number on something, then it's meaningful.
Right. And if you can, it's not meaningful. Well, that's the basis for the whole school of logical positivism.
Yeah,
and the Vienna Circle. Right. It was exactly that statement, that if you can't put a number on it, it's not meaningful. And of course, we know now that that's an erroneous assumption.
Yeah, I mean, here Israel, we are extremely technophilic right. In Israel. Right. We're the startup nation, all that shebang, and and you see now, where kids are going, what they're studying in high school, where they want to go, which units they want to go to in the army, and so forth. It's all going in that direction.
Yeah.
And it seems to me that with that cast of mind, you define your problems as a society based on their solutions. If there's a technical solution, then there's a problem. If there's not, there isn't.
Right. You're absolutely right about that. So we need to resurrect the humanities and show their relevance and their importance.
But how do we do it, Alan, without turning the humanities into a handmaiden of the sciences and the technical subjects? Without turning them into, we need scientists who are doing the really important work, and the technologists, we have to give them a little bit of ethics so they don't go, they don't go rogue. How do we inculcate the love of the thing itself, the non-utilitarian aspect, the beauty of, a poem, of a novel, of a painting, and so forth?
Well, I think you said it. It's the beauty. And I think that that 8 and 9-year-olds can respond to the beauty of a painting or a poem. Children have a natural rhythm in the way that they talk, the songs that they make up, and it's natural to them. And we just have to make sure that we don't stifle and suffocate that natural love for rhythm and beauty, novelty. So I think that the raw material is there, and the raw material is the young human mind.
How about some practical ideas? I agree, of course, but there are financial forces. There are these strong societal forces pushing young people in particular directions. How would you like to see grade schools change, for instance?
Well, I would like to see grade schools and high schools have, as much art as science in their curriculum, and take children and young people on field trips to museums, and to concerts, to ballets. In terms of where do you get the money for that, I don't know. I think it takes a recognition of the importance before we begin fundraising. We have to recognize the importance of this exposure to the arts and the humanities. And I think that, if people like you keep talking about this, then maybe you'll change some minds. There's so many clear examples of why the arts and humanities are important. So I think you could even fight fire with fire and argue on a practical basis, not as a handmaiden of science, but just important as shaping the kind of mind and imagination and the kind of human being that we want to be living in the world.
Do you feel over a long career, looking at the world from where you were sitting at Harvard, then at MIT, and on your island where you go to write, that men and women of the humanities have lessened in their impact on our culture over the last few decades? Do you feel that there's less of a voice, a strong moral voice coming from those circles, or not necessarily?
I don't think necessarily. I wouldn't be able to say that. I have seen that school systems have tilted towards STEM, and I think that that's happened worldwide. But I do think that there are still strong voices in the humanities and the arts, and we just need to listen to them. I think we also need to talk to school boards who are designing the curricula for young people, and make sure that they understand the crucial importance of the arts and humanities. Yeah.
It's one of those things where, you in order to understand it, you need to experience it rather than yes. Have it be explained to you.
Yes. Yes.
What are the challenges, would you say? Maybe this will be our last question, then I can ask you to read for us as we close out. And by the way, I'd like to remind our viewers that if you have any questions, please do send them to us, and I'd be happy to ask Alan in the time that remains. Where do you see universities going in the next generation in terms of the relationship between science and the humanities, or where would you like to see them go? If you were, czar of universities in the United States?
Well, I would many universities have core requirements where there's certain, general categories of subjects that the students have to take. And what I would like to see is that the core requirements include an equal measure of arts, humanities, and science. I know that there would be pushback from a lot of universities, and maybe even pushback from some of those in Israel, and pushback from some of those in the US as well. But that's what I would like to see at universities. And of course, universities worldwide are known for encouraging independent thinking. So I would like that to continue, of course. Critical thinking, questioning authority.
Yes. Yes. On the one, yes. On the other hand, I've also come to appreciate increasingly. I always thought that, something can come from nothing, or I had this romantic idea that something could come from nothing. And in recent years, I'm appreciating more and more the importance of models. And in a classical education, the idea was just to read Seneca and Cicero again and again and again and again, and to imitate. Plagiarism was not a bad word in the 17th century, not at all. Quite to the contrary. And the notion, the educational theory behind that was that when you copy these great sort of models time and time again, imperceptibly you begin to hear your own voice.
Right.
So somehow to allow those two things to live together in an education, in a university and anywhere. Alan, can I ask you to read for us as we close out?
Well, I'll read one more little passage. This is from my book, my most recent book, Probable Impossibilities. With the discoveries of the Kepler satellite in the last 5 years, it's almost certain that life exists elsewhere in the universe. The Kepler discoveries, plus the rarity of life in time and in space discussed here, lead to a concept I'll call cosmic biocentrism. By that, I mean that the rarity and preciousness of life provides a kinship to all living things in the universe. I can't imagine what kinds of thoughts, what kinds of values and principles other living beings might have, but we share something in the vast corridors of this cosmos we find ourselves in. What exactly is it we share? Certainly the mundane attributes of life. I'd argue that we conscious beings share something more during our relatively brief moments in the era of life. The ability to witness and reflect on the spectacle of existence, a spectacle that is at once mysterious, joyous, tragic, trembling, majestic, confusing, comic, nurturing, unpredictable, predictable, ecstatic, beautiful, cruel, sacred, devastating, exhilarating. The cosmos will grind on for eternity, long after we're gone, cold and unobserved. But for these few powers of 10, we have been, we have seen, we have felt, we have lived.
Well, that's very beautiful. Thank you for sharing it with us. And Alan, I want to tell you that you've been a model for me and continue to be, and it's a great pleasure now to have this friendship. And thank you so much for spending this hour with us.
Well, thank you, Oren. Thank you for inviting me.
Well, hope to see you soon.
Okay.
Have a good day. Bye-bye. Good evening, everyone. And we'll meet in the series in 3 weeks' time with Professor Anat Ben David from the Open University. We'll be talking about boundaries on the internet. So many interesting topics. Thank you all. Good night.
Bye.